Hi, Mr. Andrew here today, and we're going to be doing slant asymptotes. So here we have f of x equals 2x squared plus 3x minus 5 over x plus 2. So here I can tell I have a slant asymptote because the degree of the top, the degree of the numerator, is exactly 1 higher than the denominator, the bottom. In fact, the degree of the top is squared, it's a 2, and the degree of the bottom, well, that's linear, it doesn't have power, so that's technically 1. So it's higher by exactly 1. Okay? So I shift this camera. Higher by exactly 1. So what that means is I do have a slant asymptote. So here I actually have to take 2x squared plus 3x minus 5, and I have to divide it by x plus 2. Now this right here can be done with synthetic division because there's no coefficient on the x and it's got a power of 1. We could do synthetic division and get the same answer, but here that is not always applicable, so I'm going to show you the way you can always do it, and that's with long division. So here x and 2x squared, I have to multiply by 2x. In other words, 2x times x is 2x squared, so we can cancel it out. 2x times the other part of the binomial, 2x times 2, is 4x. Positive. Now I draw a line, change my signs, okay? And now going forward, I'm going to have this cancel out. I'm going to have this be negative x, positive 3 minus 4, and I drop the negative 5. I go ahead and ask myself, what times x equals negative x? Well, that's negative 1. Negative 1. Negative 1 times x is negative x. Negative 1 times 2 is negative 2. I draw a line. I change my signs. This cancels out. Minus 5 plus 2 is negative 3. Now this right here, this part right here, this is my remainder. Right here, remainder. This is my quotient, and this is actually my slant asymptote. My slant asymptote is y equals 2x minus 1. So on a graph, what would a slant asymptote kind of look like? Well, I'm just going to do a really rough sketch. If I had 2x minus 1 being its y-intercept, and I'd draw a point here, and then go up a little steeper because it's got a slope of 2. And then really what this is I almost do that wrong. It's a dashed line. It's a dashed line because it's an asymptote. Sorry that I almost drew that wrong. Now what could happen is something could do things out here, but as soon as it gets close to this, it'll start going with this line here. Same thing down here. The graph will want to follow and get close to but never touch this line. Okay? So it'll get close and touch. So you can have weird kind of shaped things. You can have them like that, but they have these slants to them. They're really cool, and that's how you do them. You just need to do long division or synthetic division if you like that better, and if it's applicable. So here, if you have any questions, don't hesitate to email me. Thank you.